In this video, I'm going to be introducing ways that we can prove congruent triangles. So we know that corresponding parts of congruent triangles are congruent, but it's not necessary to prove that all 6 parts are congruent. We don't need to prove that all 3 angles correspond and are congruent, and we don't need to prove that all 3 sides correspond and are congruent. There's some shortcuts we can take. So these are called proof methods, and we're just going to talk about 3 main ways. The first way is that we can compare sides, all 3 sides. If I can say that 3 sides of a triangle are congruent to 3 sides of another triangle, then I'm using this proof method called side, side, side. We could then name these 2 congruent triangles by making sure that we put corresponding parts in the same order. So if I name the left triangle, triangle BAC, I need to name the right triangle, triangle YXZ, because B is going to correspond with Y, A corresponds with X, and C corresponds with Z. A second way that we can prove 2 congruent triangles is by using a method called side, angle, side. We could do that by finding corresponding parts, specifically 2 sides that hug an angle or have an angle in between the 2 congruent sides. So as long as I know that 2 sides are congruent and that the angle in between them is also congruent, then we can say that the 2 triangles are congruent based on a side, angle, side proof. So if I name the left triangle, triangle CAB, I must name the right triangle, triangle XZY, so the corresponding parts are in the same order. Another method we could use is called angle side angle. That's similar to the last method we just did, except that rather than talking about 2 sides hugging an angle, now we have 2 angles hugging a side. So this is called angle side angle because I have 2 angles hugging a congruent side. And that side has to be in between the 2 angles. So if I name this left triangle, triangle BCA, to name its congruent pair, I would have to name the right triangle, triangle YZX. Again, making sure that corresponding pieces are in the exact same order. So those are the 3 main methods that we're going to be using. There are more methods. There's an angle, angle, side method. There's a hypotenuse leg method, which is specifically used for right triangles because it involves a hypotenuse. And then there's a couple of methods that you may think are possible but are not. So side, side angle is actually not a congruent method. And angle, angle, angle is also not a congruent method. Those are similarity proofs, not congruency proofs. So why is angle, angle, angle not a congruency proof? Well, if we know that corresponding angles are congruent in 2 shapes, we know the shapes are similar because angles create the type of shape. But side lengths create the size of a shape. So if I don't know that any sides are corresponding and congruent, then these 2 shapes may be 2 totally different sizes. And we can see an example here where we have 2 similar triangles. We have congruent corresponding angles, but just because the angles are the same measurement does not determine the size of the shape. We can make the lengths of these triangles any size, even if the angles are the same measurement. So not enough to determine congruency, just similarity. All right, so we're learning these types of proofs so that we can do a 2-column proof and prove that 2 triangles are congruent. So I'm going to finish off this video by just doing an example of a 2-column proof and discussing some methods that I like to use. In some following videos, we'll do a lot more examples using 2-column proofs to prove 2 congruent triangles. So in proofs, oftentimes you're given some information to start off with, and that's usually labeled given. So here we're given a couple of different statements that we can use. You'll always be given a prove statement asking you what to prove. So we're going to prove that this left triangle is congruent to the right triangle. And then you're given a 2-column proof. On the left side, you can write statements. And on the right side, you're going to provide reasons for why you said your statement. So a technique I like to use involves three steps that we just repeat. We start off with a given statement and just rewrite the given statement. And the reason for providing that statement is always because it was given. And the second step is asking yourself what that allows you to do in the diagram. What congruency symbols can you use, or what next statement can you provide based on that information? So if D is the midpoint of segment AC, then D must be right in the middle, making AD and CD equal distances, or segment AD is congruent to segment CD. So I could put a little hash mark symbol telling me that the two segments are congruent, and then I can write that statement. I know that segment AD is congruent to segment CD, and my reason is because I was told that D was a midpoint. So because of the definition of a midpoint, because I know D is in the middle of AC, I know it was broken up into two congruent segments. So there's the three steps. Use your given statement. Think about what it allows you to draw or what statement it allows you to make, and then make that statement. So let's repeat the process. Let's move on to the next given statement. Rewrite that given statement. And the reason is because it was given to us. And then think about what that means. If segment BD is perpendicular to AC, then what do I know? Well, I know that it creates two right angles here. Perpendicular lines create right angles, so I could draw boxes in the corners right here. And I now know that angle ADB and angle CDB are congruent, so that would be my next statement. And I was able to make that statement. I knew that those two angles were right angles because of the definition of perpendicular lines. So once we've used up our given statements, it's good to ask yourself, well, what proof am I working towards? So what pieces do I know are congruent so far? Well, we know that we have a segment that's congruent to another segment, and we have an angle that's congruent to another angle. So if I finish that off, I might have side angle side. That might be my congruency proof. Or if I think about that backwards, I might have angle side angle. Angle side angle. Well, I don't know anything about angles A and C based on my given information. And nothing so far has led me to believe that they are congruent. So angle side angle might not be the best method. So let's go back to that first thought. What if we had side angle side? Well, looking at segment BD, that side is shared by both of these triangles, and it must be the same for either triangle. It's part of triangle ADB, or the left triangle. It's also part of triangle CDB, or the right triangle. And it's the exact same segment regardless of whether it's on the left or right triangle. So it must be equal to itself or congruent to itself. So if segment BD is congruent to itself, then I can finish off my congruency proof. Whenever you are saying that a segment is congruent to itself, we always use this reason. It's called the reflexive property. And that just means that something is congruent to itself. So now I have all of my pieces. I have a segment, I have an angle, and I have another segment. So the last statement you always provide is the prove statement. I know these two triangles are congruent because I said that they have congruent side angle side parts. So there's an introduction to a two-column proof and some three methods that we could be using. We'll do some more proofs in some later videos.